Hey guys, my name is Jacob Van Dornward. This is my project for my MAT 271 calculus class. And basically, what we're going to be covering is some practice problems for the upcoming final exam. So let's go ahead and get right into it. So I'm going to read the first problem. It's going to be on related rates, and then we're going to transfer over to actually solving this problem. Okay. So the problem states a 20-foot ladder leans against a wall. The base of the ladder slides horizontally away from the wall at a rate of 4 feet per second. As a result, the top of the ladder moves down the wall. And at what rate is the top of the ladder sliding down the wall when the base is 16 feet from it? Okay. So as you can see, there's a picture up there that I created. We're going to just go into my workspace. And we're going to go ahead and redraw the picture as we're not going to be able to see the problem right now. So I'm just going to draw this out first. So we have our x and our y axis. Okay. And this will be our ladder. And so the ladder is going to be 20 feet as stated in the problem. And it said it was going to be moving away from it at a rate of 4 feet per second. Okay. All right. And so we don't know what h is, and that's basically the height from the top of the ladder to the base. And also we're going to go ahead and label this as x, the feet away from the wall. Now it did say in the problem that it was 8 feet away, but we cannot go ahead and put that in there since it's always changing because of that rate right here. Okay. All right. And then we're also going to label this part right up here as dHdt. This is the rate that the top of the ladder is moving towards the bottom. And it's going to be a negative number because it's going downward towards. And that's going to matter when we go ahead and solve the problem next. Okay. So we drew our picture. That's the first step. The next step is we're going to find a relation between x and y and write an equation that relates the quantities. Okay. So more often than not, when you're doing related rates, you're going to be using the Pythagorean theorem most often. So let's go ahead and try that. It's going to be a squared plus b squared equals c squared. So we don't have our a squared or b squared. So our a squared is going to be x squared and then plus h squared. And that's going to equal 20 squared, which is going to be 400. Okay. All right, and now since we have our equation that relates all the quantities together, we're going to go ahead and take the next step, and we're going to take the derivative of both sides. So of this side and this side with respect to time. Okay, so it's going to be d, the derivative of d over dt of x squared plus h squared equals the derivative with respect to time of 400. Okay. All right. Now, when we're taking the derivative, we have to remember that we're going to use the chain rule. So we're going to do, first we're going to move the exponent for x to the front, which is going to give us 2x. And then we're also going to take the derivative with respect to x, which would be dx dt in respect to time. Okay. And then we're also going to do the same thing for h. It's going to pretty much be the exact same thing, 2h times the derivative of h with respect to time. Okay. And as we know, constant's derivative is going to be 0. Okay. And then if you're confused on why we do this, because of the chain rule, basically states that we are taking the derivative of x squared first of that exponent with respect to x. And then we're also going to take the derivative of x with respect to time. Okay, so that's why we're doing that. And that can go for both x over here and h over here. Okay. Okay. So now that we took the derivative of that, now we're going to go ahead and plug in, one second. Yeah, so we're going to go ahead and, since we took the derivative of that, we know at the rate of 4 feet per second over here, we know what that distance is from the wall, or from the base of the ladder right here from the wall, is going to be at 8 8 feet, because it tells us that in the problem where it says, or sorry, not 8 feet, 16 feet. Is going to be at 16 feet because it's sliding down the wall when the rate is at 4 feet per second when the ladder's from that. Okay, so we're going to go ahead and rewrite that Pythagorean theorem again. But instead of x, we're going to use 8 instead. Okay, so I'm going to do that right over here. It's going to be, sorry, I keep saying 8, 16. So 16 squared plus h squared equals 400. Okay, and the reason why we're doing this is we're trying to find all the variables that are going to be able to solve, and we're trying to find our missing variable that we cannot find, which we will figure out which one is that. It's going to be dh of dt. This is what we're trying to find right here. Okay, so 16 squared is going to be 256. That's going to be plus h squared equals 400. Subtracting 256 from 400, that's going to give us 144. And then we're taking the square root of both sides. Now, it would be plus or minus, but since this is a real world problem and a ladder cannot be underground, we're going to only use the positive version of this. Okay, so it's just going to be h equals 12. Okay, and now we have our height. So we have x equals 8 at 4 feet per second, and then h equals 12 at 4 feet per second. Dx dt, which is going to be our rate with respect to x right here. Looks like a y, x, there we go. Dx dt is going to be 4. Okay, and we don't know what dh of dt is because that's the one we're going to be trying to solve for, okay? All right. And so with that information, we're just going to plug in all the numbers that we have, and then we're going to solve for our missing variable, dh of dt, and then we'll have our answer. So let's go ahead and plug this in. So it's going to be 2 times x is, I keep saying 8. 2 times 16 times dx dt, which is 4. We're going to add 2 times 12 times dh dt, since we don't know what that is, and then equaling it to 0. Equal to 0. Okay. Okay. And then we're going to go ahead and solve. So it's going to be 2 times 16 times 4, and that's going to give us a total of 128. And then 2 times 12 is going to be 24, but then also times dh dt, okay? Equaling it to 0. Then we're just going to do some simple algebra. Subtract 128 to both sides. 24 dh dt equals negative 128. Divide both sides by 24. And then we have our answer for dh dt, which equals negative 128 over 24. But if you simplify that, it would give you negative 16/3. Okay. Now it's good that it's the reason why it's a negative number is because, as it stated in the problem in the beginning, it said the top of the base was moving towards the base of the top of the ladder was moving towards the bottom, and since that means the angle right here is going to be constantly decreasing. That's why we have that downward arrow there, because the bottom or the top of the ladder is moving towards the bottom. And so that's why that number is negative. And then that is our answer, dh dt. That's what we're trying to solve.